join. Good afternoon, all the participants, and also a special welcome to our speaker, Professor Priyoranjan Das and Dr. Tirthankar Ghosh, our IQAC coordinator, Dr. Alpana Roy. Hello, sir. Am I audible?
Audible. Everything is audible.
Okay, ma'am. Okay, today is the second day of sounded problem করছে
Hello.
Yes, sir.
Am I audible?
Yes, sir.
So here some network.
There is no echo হচ্ছে আসলে
ইকো হচ্ছে হ্যাঁ
Shall we start?
Okay, sir. Now we are going to begin our session. Good afternoon, all the participants and my dear colleagues, and also a special welcome to our speaker, Professor Priyoranjan Das and Dr. Tirthankar Ghosh, our IQAC coordinator, Dr. Alpana Roy. Today is the second day of national level e-workshop on fundamentals of R programming. Yesterday, we had a very informative and interactive session in which we had learned about R programming. Now, I would request our IQAC coordinator, Dr. Alpana Roy, to deliver keynote address. Over to you, ma'am.
নমস্কার এখানে সকল আমি বাংলাতেই বলি যেহেতু আমি দেখলাম এখানে সবগুলো পার্টিসিপেন্টই প্রায় বাঙাল মানে আমাদের বেঙ্গল থেকেই আছে বলে আমি তো তাদের উদ্দেশ্যেই বলি Good afternoon to all of you, my dear colleagues, my friends, and everyone, and the respected resource person also. আজকে আমাদের এই ওয়ার্কশপটার দ্বিতীয় দিন কালকে আমরা প্রফেসর ডক্টর তীর্থঙ্কর ঘোষ স্যারের থেকে আমরা যা শুনেছি তার দ্বারা আমাদের এই ওয়ার্কশপের সমস্ত পার্টিসিপেন্টরা আমরা সমৃদ্ধ হয়েছি আজকে সেই ওয়ার্কশপটারই দ্বিতীয় দিন এবং আজকে আমাদের কাছে যিনি আছেন তিনি যাকে পেয়ে আমরা ধন্য হয়েছি সেই স্যার তিনি হলেন ডক্টর প্রিয়রঞ্জন দাস প্রফেসর হেড অফ দ্য ডিপার্টমেন্ট অফ স্ট্যাটিস্টিক্স ভুবনেশ্বর উৎকল ইউনিভার্সিটি ভুবনেশ্বর স্যারকে অনেক 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 ধন্যবাদ স্যার তার মূল্যবান সময় আমাদেরকে দিয়েছেন এবং আমাদের এই ম্যাথামেটিক্স কম্পিউটার সায়েন্স আইকিউএসি দ্বারা আয়োজিত যে আর ওয়ার্কশপে তিনি তার মূল্যবান সময় দিয়ে আমাদের সাথে উপস্থিত হতে পেরেছেন এবং আমাদেরকে এই যে ওয়ার্কশপটার যে সফটওয়্যারটা শেখানোর জন্য স্যারের যে সময় তার জন্য স্যারকে অসংখ্য কৃতজ্ঞতা জানাই। যদিও মানে আমাদের রিসার্চ করার সময় এবং ছাত্রছাত্রীদের সময় ভীষণভাবে কাজে লাগে, ইভেন আমাদেরও, যদিও সাবজেক্টটা আমি জিওগ্রাফি, কিন্তু এখন আমাদের রিসার্চ করতে গেলে, ভালো ভালো পেপারে জার্নাল পাবলিশ করতে গেলে সফটওয়্যারটা ছাড়া আমাদের ভালোভাবে ডেটাকে রান করতে পারি না। সুতরাং এই সফটওয়্যারটা শেখা আমাদের রিসার্চ স্কলার থেকে এবং স্টুডেন্ট সবার জন্যই খুবই জরুরি। এবং যদিও এটা ঠিক দুদিনের মধ্যে, আমি স্যারও আমার সাথে মনে হয় সহমত হবেন যে দুদিনের মধ্যেই পুরো বিষয়টাকে সাম আপ করে আনা অসম্ভব ব্যাপার, শিখতে একটু সময় লাগে, কিন্তু স্যার আমাদের কাছে তাও চেষ্টা করবেন, তিনি তার মূল্যবান জিনিসগুলো আমাদের সাথে শেয়ার করবেন, আমরা একটা গাইডলাইন পাবো। স্যারের টোটাল প্রচুর ন্যাশনাল এবং ইন্টারন্যাশনাল পেপার আছে, প্রায় ওনার 24টা ন্যাশনাল পাবলিকেশন এবং 16টা ইন্টারন্যাশনাল পাবলিকেশন আছে। এমন ব্যক্তিকে আমরা রিসোর্স পার্সন হিসেবে পাওয়ার জন্য আমরা সত্যি সমৃদ্ধ হয়েছি আমাদের এই ওয়ার্কশপটা। আশা করি ছাত্রছাত্রী যারা এখানে আছো তারা এখানে সমৃদ্ধ হবে। রিসার্চ স্কলাররাও এখানে অনেকে দেখলাম যে তাদের প্রোফাইলে তারা আছেন, তারা আশা করি তারা কিছুটা হলেও একটা গাইডলাইন পাবে এবং তাদের মানে ভবিষ্যতে যাতে আরো ভালো করে জিনিসটা অর্গানাইজ করা যায় সেই প্রচেষ্টা আমরা করব। অনেক ধন্যবাদ। আমি ডিপার্টমেন্ট অফ স্ট্যাটিস্টিক্স এবং আপনাকে আপনার অনেক ধন্যবাদ জানাচ্ছি, এবং কম্পিউটার সায়েন্স ডিপার্টমেন্ট এবং এখানে যারা ম্যাথস ডিপার্টমেন্টের টিচার আছেন তাদের সবাইকেই, তাদের দ্বারা যে আয়োজিত হয়েছে এই ওয়ার্কশপটা, আমরা সত্যি সবাইকে আমি কৃতজ্ঞতা জানিয়ে আমার আজকে ছোট্ট অল্প কিছু বক্তব্য আমি শেষ করলাম। অসংখ্য ধন্যবাদ সুপর্ণাকে, নেহাকে।
নমস্কার।
নমস্কার।
Thank you, madam. Thank you very much. Now I request Neha Gorui from Department of Mathematics to introduce our speaker.
Good afternoon, professors and students. Today we are pleased to invite our eminent speaker, Dr. Priyaranjan Das, who is a professor and head of the Department of Statistics, Utkal University, Bhubaneswar. He is a great researcher with numerous international publications. His research includes probability theory, stochastic process, and sample survey methods. He is having a teaching experience of 24 years at both undergraduate and postgraduate level. We are very happy that we have got this opportunity that sir will be delivering the lecture on R programming today. So I would like to request sir to start with the session. Over to you, sir. Thank you.
Thank you. Good evening. Namaskar to all of you, respected principal, chairman, IQAC, head of the department mathematics, head of the department computer science, and my dear participants. Now yesterday we have, my friend, he has covered some basics of R, covering different data types. Now in this session I will cover up about the different control structures and how to handle different loops in R. Now let us start. Now is the screen visible? Now, welcome to all of you to this session. And in this session, we shall cover some basics relating to the control structures, function, different apply family functions, and what are the coding standards in R. Now, first, go to the control structure. Now, for the control structure, consider the quadratic equation. We want to solve this quadratic equation. We have to find the roots of this quadratic equation. Suppose ax square plus bx plus c equal to 0. Ax is the unknown. A, B, C are the known numbers. And we generally assume that A is not equal to 0 because once A will be 0, this will be linear. It will not be a quadratic. So, here the numbers A, B, C, they are the coefficients. Depending upon the value of the A, B, C, we find the roots. And for the roots, we have to find the value of the discriminant D, that is B square minus 4AC. We have if A D greater than 0, then there are two roots of this quadratic equation ax square plus bx plus c. They are real and different, and the roots are given by minus b by 2a plus minus root over d by 2a. And when this discriminant d is equal to 0, then both the roots will be equal, and the roots are equal to x equal to minus b by 2a. And if d less than 0, then root over d, it is not real, it will be an imaginary, so no real roots. So in this way, we find a solution of this quadratic equation ax square plus bx plus c equal to 0. Am I right? Now this is in this session we should interact rather than I will tell every time. We shall interact, and just like interaction between friends. So you are always welcome to ask the questions in between. I am avoiding the chat box because when I am sharing the full screen, I am not able to see the chat box. So you can ask directly. So now, in this session, even though I shall try to cover all these 4 parts, you are free to interact in between. And whenever you are facing any problem in understanding the basic concepts, then you can also ask. Now see, this is the way we are finding the solution of this quadratic equation, and the known numbers here A, B and C. So to find the roots, we should first know the value of A, B, C, right? Yes or no?
Yes, sir.
So we shall go for a R programming where we have to find the roots of this equation. I am starting from the example so that you can able to understand different parts of a program and how these control structures are used. Now let us see. Now I have to use the values of A, B, C in order to find a solution. So my solution, this is in the form of a formula x equal to minus b by 2a plus and minus root over of d divided by 2a, where D equal to B square minus 4AC. Now for this, I have to define a function. So my result, the values of the roots x. Now it is a function of ABC. I define this result, and this less than minus sign. This is the result. I assign the value of this function to result. So result is a variable whose value is to be determined by this function. So how I define the function? This is a function of a, b and c. So I write within bracket function abc, and I define the function within this curly bracket. So before going to the finding the value of x, I have to check what is the value of d. So d is equal to b square minus 4ac. So I find delta, that is d abc, if it is greater than 0. This is the first case, d greater than 0. So there are two roots, x1 and x2. So minus b plus square root of delta means b square minus 4ac by 2a, x2 minus b minus square root of d by 2a. So result will be the value of x1 and x2. This is first part when d greater than 0. When the second part, both x1 and x2 are equal and they are equal to minus b by 2a. So this is when delta ABC, this is equal to 0. And otherwise, if d less than 0, then there is no real root. And I define here delta function of ABC b square minus 4ac. So before finding the root, I have to check the sign of
Sir,
d.
am I audible to you, sir?
Hello.
Am I audible to you, sir?
Yes.
Sir, else if you have written x is equals to, this is the repeated root. So we will just write result is equals to c of x comma x.
Now, I am not going to how I have written the program. I am going to only check the sign of d, whether it is positive or 0 or negative. So depending upon it will calculate the value of x. So first it will check the condition. What is the sign of d? So here I have considered three conditions: d greater than 0, d equal to 0, d less than 0. And these conditions I want to input through R. So I have used for verifying this condition, the statement is if, else if, and else. So here this if and else if, these two statements, they verify a condition before finding the roots. That is the objective. Clear?
No, sir, I'm asking that as in the if statement, there is a return value of result. So similarly, in the else if statement, do we have to return the result value also? When we should be right, or we will get
x. I have written in the second line x equal to minus b by 2a.
Yes. So should
and
we
the third else also,
result is equals to this, or x enough? If writing this will be, will get the result.
Now we will get the result. I am writing x because in the previous case there are two values of x, and here both the values are equal, so I write x equal to minus b by 2. Both the values are equal here because d equal to 0. Both the roots are equal. And in third case, if d less than 0, the result will come as there are no real roots. It will display there are no real roots. We shall now verify this. Now, is the R screen visible?
Yes, sir.
Here it is the program. I shall run one by one, constructing quadratic formula. Here I have defined delta. Then run this result. Then I shall put the values of A, B, C. If I shall put the values of A, B, C, see, I am using this function. Result 4 minus 1, 5 means A equal to 4, B equal to minus 1, C equal to 5. So my equation is 4x square minus x plus 5 equal to 0. So when I put this, it is writing there are no real roots. If I shall put suppose x square minus 2x plus 1, suppose this is equal to 0. Then if I run and x square minus 2x plus 1 equal to 0, if I run, then the value of x will be 1 because the roots are equal. If I shall take another equation, change this one, 2, 1, 1 means 2x square plus x plus 1 equal to 0. So A, B, C values are 2, 1, 1. So when I run this, and here there are no real roots. If we find b square minus 4ac, b is equal to 1, b square 1 minus 4 into 2 into 1, 1 minus 8. So minus 7, d less than 0. So it is displaying there are no real roots. Okay, is it clear? Now, I shall go to, now here, I am only using, displaying how if and else if are used in a program. So they are controlling the value of the root. Now how these conditional statements they are used, we shall go a little bit now. Now for that, so here the flow of control for the execution of a series of R expression, and these statements allow us to put some logic into the R code. so that the R code will be executed to find the result. Now, commonly used control structure, one is if and else, that I have already used here. If else function. If and else, this is used to test for testing a condition and acting on it. If also the same way we can use. Then there is another statement called switch statement. Then for, while, then break, repeat, and next. So these are the various 8 commonly used control structures which are used in R. Now we shall go in detail one by one. Okay. Now the control structure, first we have considered if and else. Now see, this is the syntax. If there is a condition, curly bracket starts, then it will do something, whatever we will write these statements. That means if this condition is true, then it will perform this job, else it will perform this job, do something else. The curly bracket ends. So here, this is the general syntax for using if else. Now it is clear. Now how it works, we shall verify. We consider two numbers A and B. I assign A and B as the value of 5, 6. A is 5, B is 6. Now, if A less than B, this is the condition I have put. If A less than B, then it will print A is smaller than B. If this condition is not satisfied, it will write now it will write A is smaller than B. If this condition is satisfied. Suppose another x is 1 to 15. If x is the sample x1 less than equal to 10. So that means I am selecting a number from 1 to 15. Sample x, 1, that means it will select randomly one of the number from 1 to 15. If it is less than equal to 10, that means this is the condition we have put. If the selected number is less than equal to 10, then it will print x is less than 10, else print x is greater than 10. Now in the previous we have used only if statement. There was no else condition. That means it will execute if only the condition that we have specified is true. Otherwise it will go out of the loop. So here we have put two different conditions, one condition with two different sets of statements. It will execute as the condition is true or as the condition is false. It will set, display or perform another set. So let us verify this. So here I have taken A is 5. I run now A is 5, B is 6. Now this condition, if A less than B, so here A less than B, so it now prints A is smaller than B. Suppose I take A is 10, B is 6. Here A less than B, this is not true. Now let us see what it does. A 10, B 6, and now I run this condition. If A less than B, print A is smaller than B. So what happens here? If A greater than B, here what prints? A is greater than B. Because here we have taken A is 10, B is 6. Now it is clear? Hello?
Yes, sir.
Yes, sir.
Okay. Now if else if use, we have studied. Now take another example here. I am taking a sample from 1 to 15 that here I have taken the value of x 1 to 15. Now here in this, if sample x comma 1 less than equal to 10, that means it will select a random value from 1 to 15. If that is less than 10, then it will print x is less than 10, else it will print x is greater than 10. Now I run this one. Here that number a is less than, x is less than 10. Now if I write x here, now it will, if I assign this function, you can see x 1 to 15. Now from 1 to 15, it's randomly select a number. So in this case, it find x is less than 10. That means the random number which was selected, it is in between 1 to 9. Now, here I have to write what is x, the value of x, print x. Here I have to give a statement that is print. Only I can write only x. Suppose I am writing another value. Now this is the value. If I run this, again the y will change. 10. Next random number 11 is selected. Next number 5 is selected. So like this, value, random value. Okay. Hello. Suppose I have to select two numbers. So here I have to write y sample x 2. So I run, then run y. So two values selected, 3 and 2. So to get this number, which number is selected, I have to write like this. Okay. Am I clear?
Yes, sir.
Yes, sir.
Okay. Now, similar function can be done by if-else condition, if-else function. Now, if-else function, its role is just like if-else structure that we have discussed previously, and its syntax is if-else, we are writing the condition and both the statements within one parenthesis. So it will execute the first condition, the first statements, first group of statements if the condition is true, and the second if the condition is false. Now here I took x as 7, so x is 7. So here I put the condition, if else x less than 5, it will execute x is less than 5. Otherwise, it will write x is greater than 5. Now see, I have taken x is 7. So x means it will print the value of x. So here in this line, I am writing if else, and the condition is x less than 5. And the first part is x less than 5. If this condition is true, it will write x less than 5. Otherwise, if it is false, it will write x greater than 5. So the difference between the previous one and this one is that both are written within a parent. Here, all the condition and the statements, they are written within one parenthesis. Now, you can see, here I have taken x is 7. So I now run this. So see, here x is greater than 5. So if I will x 10, suppose, here it is writing x is greater than 5. So I take x equal to suppose 1. Here x is less than 5. So now the difference between the previous one and this one, in the previous one, we have putting the condition outside and within curly bracket, we are writing both the statements, both the groups of statements. First group is executed when the condition is true. Second group is executed when the condition is false. But in if else, there is a difference. The condition and both the two groups are written within a parenthesis. So that is the difference. So this is the difference. It is written in one line. Now another, that is switch statement. When we have multiple alternatives, else, if else, we can use different loops within that. One nested if we can use, but alternatively, here in R, we can use switch statement. So when we have several alternatives. So here, for example, A is 4, I am writing. So switch A, 1, this is the first case in the switch. 2, this is the second case in the switch. 3, this is the third case. 4, this is the fourth case. 5, this is the fifth case. Now, I have to, here we have 5 different alternatives are to be shown. So, let us see. Here I am writing A is 4, switch A. So, A is equal to 4. So, this is the fourth case in the switch. So, A equal to 4. So, 1, 2, 3, 4, these are the values of A. Depending upon the values of A, it will write this one. So, suppose I take A equal to 5 or A equal to 2. This is the second case in the switch. So, what the value we shall put here as the value of A, it will execute or it will perform the action accordingly. So, this is here we have 5 different alternatives to perform. So, one of the alternative of the if else statement is the switch statement. If else, it is executed when we have two alternatives. One is executed when the condition is true, other is when it is false. But in the switch statement, it is able to handle several statements or alternatives simultaneously. So that is the difference. Now it is clear.
Yes, sir.
Now, the third, you can take here, suppose I take A equal to suppose 2.5. Let I take A equal to 2.5. Here, among these alternatives, A, 1, 2, 3, 4, 5, here I have to write accordingly. So 2 means, suppose I have to write 2.5. Suppose I shall write A equal to 2.5, but here I will not put any value. Here only 1, 2, 3, 4, 5. 2.5 is not there. See, I am taking a different value. A is 55, which is not here, or 7.5 I can take also, which is not here. I have specified the values 1, 2, 3, 4, 5. So if I run, it just skip away the switch statement, because it will check whether this value is within this or not. So 7.5 is not here. So it will just skip this switch statement. You can take any value. No, that previous, it was already in the memory. I have not cleared. That is why it is showing second case. That is why here now I have changed to another value, 7.5, or you can, even if you can take 10.5. 10.5 is not here. So it will just skip. If I will give here again 2.5, because it is already in the memory, so it will write this is the second case. Is 2.5. This is the second case in the switch. But because I have changed this one, this is already, it is in the memory that 2.5 is the second case. So that is why it is writing like this. But here this value is to be verified from this. One of the values should be equal to this. Otherwise, this switch statement will be skipped.
Sir, is there any option to take default option, that means the default value, apart from 1, 2, 3, 4, 5? If it is other than that, can that be specified?
Suppose I am taking a value 50. A is 50. So within switch, it is not there. 1, 2, 3, 4, 5, it is not there. So now if I run this, it will just skip the switch statement, because it will not find any alternative according to the value of 50. See here, there is no output. It is just skipping. That means the value, we shall put the value of A here. It will verify which alternative is corresponding to the value, that is the value of A. If it will not find that, then it will just skip away. Okay. Am I clear? Now there is a for loop. A for loop, it works just an iterable variable and assigns successive values till the end of the sequence. So for variable in the sequence, it will execute different codes that will to be repeated, and otherwise it will go away from the for loop. So for I in 1 to 10, print I. That means when it will execute one by one, I equal to 1, I equal to 2, similarly I equal to 10. And once 10 is reached, it will go out of. So that means it will print here the value of I. See. Now another also an alternative to this. Here print I am writing within the curly bracket. So here also I can avoid the curly bracket. See. I in 1 to 4 print xi, because I have not given the values of x here. So that is why it is writing NA means it is not available. So before writing this command xi, I have to give in the value of x. So here, that is why I have put here the x equal to A, B, C, D, 4 values. For I in 1 to 4, print xi, A, B, C, D. Suppose I shall put here 5. I have given 4 values. So see, it will write A, B, C, D. The 5th value is not available, so it is writing NA. Clear? Hello.
आपका तबीयत ठीक है?
So next, another nested loops, nested for loops.
ये क्या है आपका इससे अदवार ना ऑफिशियल
Both चल रहे हैं. So one is the nested for loop. These are commonly used in multidimensional data structure. That means when we are writing matrix, it is in the form of rows and columns. Your matrix, the elements are arranged in the form of rows and columns. So matrix is a two-dimensional data. So here, nested for loop, it works in both the dimensions, two dimensions simultaneously. So here I shall take the value of Ax, it is a matrix, 2 by 3 matrix, using the elements 1 to 6. Hello. So here we have taken a matrix with 6 elements, 1 to 6, 2 by 3 matrix. So here the general form is first it will check in rows and then columns. I am writing for I in sequential, I in sequence from length of the n row, length n row in number of rows of x. So I value will vary from 1 to number of rows. And then it will verify j 1 to number of columns, n columns, n col. And then it will print xij, then means values of the elements of the matrix one by one. So here I am using for loop in two dimensions. One is along the rows, another along the columns. So now here you can see the matrix X 1 to 6. See, the value of the matrix is 1, 3, 5, 2, 4, 6. So this is first row 1, 3, 5. Second row 2, 4, 6. First column 1, 2. Second column 3, 4. Third column 5, 6. So now I am using this for statement for printing the elements of the matrix one by one. So here I run. So 1, 3, 5, 2, 4, 6. So that means when I am giving I in sequence length rows, it will go to first row. It will go to first row and change the columns, means inner for loop will be executed first. So n row equal to 1. So columns will change 1, 2, 3. So that is why the print comes 1, 3, 5. So once all the columns are executed, it will go to the second row. Second row, then it will print second row first column, second row second column, second row third column. Means 2, 4, 6. That is why it is writing 1, 3, 5, 2, 4, 6. Now it is clear?
आपका कंट्रीब्यूशन रखेंगे नेक्स्ट वीक लेके जाएंगे
One colon, we can write 1 colon n row x and 1 colon n row n column x also. Like this, we can write down. In this way also we can do it. Am I clear? I can also write, suppose M n row x n here M and small x. So M is 2, n is 3. I can write here 1 to M and n. The answer will be same. Am I clear? Hello.
Yes, sir.
Here I am taking M and two variables. M is the number of rows, N is the number of columns. Now, the next control structure is while loop. The while loop in R, it evaluates a condition. If the condition is true, it goes through a block of codes. And if it is false, it exits the loop. So, the code block is executed when the condition is true. So, while the condition code to run, then curly bracket ends. The syntax is while we are giving the condition within parenthesis, then within the curly bracket we have to give the codes. That means if this condition is true, these codes are executed, otherwise it will go out of the while loop. So here I am writing I as 0, while I less than 10, print, paste, this is the iteration number I. That means it will start from 0 and reach until 9 because it is strictly less than 10. So then I will increase by +1. I will be I +1. So this is the output. If I will start I equal to 1, okay, is it clear?
Yes, sir.
Paste means it will write the individually one by one the values of I. It will start I from, it will start I from 0, and then for all values of I it will be printed. So that is why I am using paste. Otherwise it will write only for the last value. This is the iteration number 9. Only this line will be printed. Okay, but here we have to take care that this loop must end somewhere. That otherwise there may be some infinite loops. For example, I take here I take I is equal to 1. So I put I is 1. So while I greater than 0, I is 1 I have taken. While I greater than 0 means this condition is always true. Yes or no? I put I is 1 while I greater than 0. That means I is 1 means I greater than 0. This condition is always satisfied. Print and paste. This is iteration number I. Then I will be I plus 1. It will increase. If I run this, let us see. I is 1. That means what is happening? Here the loop will never end. It will continue, continue, continue. So this is, that means it will continue infinite number of times because there is no end to it. Because every time this condition is satisfied. So while writing a program, we have to avoid this kind of error. Okay. Now another, that is a break statement. So break statement we have to use when we have to, in a for loop we are using iterations from starting value to end value. But suppose we have to continue a fixed number of iterations, then we have to come out of the loop. Then we have to use a break statement. So here, for example, I have taken a vector VEC, this is a variable, these values C1 to 10. So what are the values of VEC? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values. So now when I put the condition for I in VEC, that means I will be from 1 to 10. So these statements are to be executed till I reach the value 10. But suppose I have to go out of the loop once the value 7 is reached. Then we have to use the statement break. So break statement is used when we have to break the loop in between before reaching the final value. So the syntax is for I in, this is the condition, print, paste, this is the iteration number I, this is the statement. If I is equal to 7, that means this condition, this is the logical operator double equal to. It will verify I equal to 7, then it will print break. Then it will write break, then loop ends. So that means here this will be the output. This is the iteration number 1, 2, 3, 4, 5, 6. Once 7 is reached, it will write break. we can see here, we take VEC 1 to 10, I in C, it will write, this is the iteration number 1, 2, 3, 4. Once 7 is reached, it is writing break. Okay. Take another example, another control structure, that is repeat loop. The repeat loop in R initiates an infinite loop from the get code. The only way to get out of the loop is to use the break statement. But repeat loop is useful when you do not know the required number of iterations. In break, suppose we know the iterations, we have to break at the iteration number 7. Then at that point we can use break statement. But here, suppose we do not know that condition. So we have to search a number from a series. Once we find, suppose we have to search a number 5 from a set of, sorry, the screen not visible. Just now, let me check. Now it is visible. Is it visible now? Hello. I am just now resharing. Now it is visible. Hello.
Yes.
Hello. Is it visible now?
No, sir.
No, sir.
No, sir.
Achha. Okay. More data connectors. Hello. Hello.
Yes, sir.
Now the screen is.
So we can hear you, but the screen is not visible.
Now, is it visible?
Yes, sir.
Okay. Due to problems, sometimes now the best technique we have used. Once we know where we have to stop, repeat is used when we do not know where we have to stop. Now, for example, we take, I define a value, variable V2, is the value from 1 to 40. I take x is 15 and I is 1. I repeat this. If I equal to x, then print found it. Otherwise, it will print not found. And then it will go to I equal to I plus 1. So when it is found, it will break. And it will continue until it is not found. Now see, I define this BEC to 1 to 40. So that means values are from 1 to 40. X is 15. So I is 1. I repeat. You can see not found, not found, not found. At this place, it found and it stops here. So here, the difference with break statement is that a break statement is used when we know the number of iterations to perform to come out of the for loop. But repeat, it is to be used when we do not know exactly how many iterations we have to perform. So that is the difference between the break statement and repeat statement. Now another kind of control structure is next statement. Next statement in R, it causes loop to skip to the next current iteration. For example, I take the value BEC. This is the variable from 1 to 10, takes the value 1 to 10. For I in BEC, it will verify if I is equal to 5 or I equal to 7, print next. Then it will go to next, print and paste. This is the iteration number I. You can see at the iteration number 5 and 7, it will print next. And in all other iterations from 1 to 10, it will write this is the iteration number I. So this is the outcome. Now, here, the values of BEC is 1 to 10. You can verify BEC, its values are 1 to 10. And then here it will verify for I in BEC. This. Exactly see at the if I equal to 5 or I equal to 7, it will print next. And in all other cases, it will print the iteration number. See, this is the 5th, it is writing next. In 7th, it is writing next. And in all other cases, it is writing the iteration number. Now, another example here, we can see this is, suppose we have a matrix. A is a matrix. This is the matrix A I have taken. To find the transpose, I just type T. This is the transpose of A. That means rows are changed into columns. So this is a single line command TA. This is built-in function. By typing TA, it will transpose the matrix. Now for this we have to, if you write the program, line by line program to find the transpose of a matrix, I have to use a function. So mine transpose, here I am using function X. If matrix X, warning, argument is not a matrix, a returning NA, a return NA real. And otherwise Y, this is matrix 1 in row 2 in column. And here in this Y, the rows and columns are interchanged. Number of rows is equal to the number of column of the previous matrix X, and number of column is number of rows of X. So Y is the transpose of X. And then for I is 1 to n row X and j in 1 in column X, Yji, that is equal to Xij. That means ijth element of X is now coming to jith element of Y. So Y is the transpose of X. Then return Y. It will return the value of Y, that is the transpose of X. Now I am finding this transpose of a matrix. So I am taking the matrix Z. This is Z matrix. It has 5 rows and 2 columns. Tz, that is my transpose Z. Tz, if I write Tz, this is just the transpose of the previous matrix Z. So by this function, I am writing or changing the matrix to find its transpose. Now these control statements that we have studied, they control the flow of the R program. That is why they are called as the control statements. These structures can be used in all combinations with each other. We can, for different scenarios, and we can implement them to solve the problem. In practice, we can use several control statements within one program. Now, let us come to the apply family. Here these are few examples. Apply function family. We have apply, S apply, L apply, T apply, M apply, and there is another function, split function. Now we shall consider this one by one. The simplest apply family member is apply. So when we have to use the apply collection, it is used to avoid the explicit use of loop constructs. For example, apply function, we can consider a data frame or a data matrix as an input and gives the output as a vector or a list or an array by using apply function. So apply function is used only to the data frame or a matrix. They are the input, and output can be a vector or list or an array. So apply function changes the data type. It changes the data frame or data matrix into vector, list or array. Now let us see when it is used. Consider an example. So this is the syntax: apply X margin function. So apply X. X is array or matrix. This is the input. Margin, we can give margin equal to 1. So when input is data matrix or data frame, it is a two-dimensional data. So we can, the margin is equal to 1 if the manipulation is to be done in rows, and margin equal to 2 if it is manipulated along columns, and margin we can write C12 also if it is to be manipulated both on rows and columns simultaneously. And function, this function can be a built-in function, or also we can define a user-defined function here. So here the value of X, we have to remember, it is a two-dimensional input. That means it is either in the form of a matrix or a data frame. So let us see an example. Here I have used a matrix M1. In place of this margin, I am writing 2. 2 means it will perform along the column. Sum means it will find the column sum of a matrix. So I use apply M1. M1 is a matrix. 2 means it is for the column. Sum means it will find the column sum of the matrix M1. If I shall write 1 here, it will find the row sum of the matrix M1. Now, clear in using apply function? Now I have to take M1. It is a matrix from with elements 1 to 10. Number of rows is 5, number of columns 6. So M1, this is the matrix. M1, this is the matrix. So here this is the matrix. Now I am applying M1. Here I am writing 2 for finding the column sums, and this is sum. Here this is first column 1, 2, 3, 4, 5. Sum is 15. 6, 7, 8, 9, 10. Sum is 40. 1, 2, 3, 4, 5, 15, 40, like this. If I shall write 1 in place of 2. So this is AM2. Apply M1. Here 1 sum. It will find the row sums. AM2. This is the row sums. If I will write here in place of sum, I will write mean. So that means it will find the average of the rows. M2. If I will find the standard deviation here, type standard deviation, it will find the standard deviation of the different rows. That is AM2. So for applying both row to rows and columns, that means it will be used in element wise. So I am writing AM3 is this sum. Sum means C1, 2. I am writing for column and rows both. So same matrix will be the outcome. AM3, this will be same as the matrix M1. In place of 1, 2, if I interchange 2, 1, then it will just transpose. Oh, sorry. For apply M1, C21, M1. In place of 1, 2, just interchange 2, 1. So what will happen here? It will just transpose because I have interchanged a row and column here, 1, 2 to 2, 1. So it will just find the transpose of the previous matrix. So here we have seen the 3 different ways of finding the transpose. One is by using command T bracket, another by defining a function, here by using apply function. So we have found 3 different ways for finding the transpose of a matrix. Now it is clear. Hello.
Yes, sir.
Now we have studied that apply function can be used both for a matrix and a data frame. Because matrix and data frame are both two-dimensional objects. Now here we have an example of a data frame. Here data frame DF we have defined the value three variables x, y, z. X values are from 1 to 4, y values are from 5 to 8, z values are from 10 to 13. So here DF. So this is our data frame x, y, z. Now I have use apply function to find the sum of the values of x, sum of the value of y, sum of the values of z. So that means column sums we have to find. So in this case, what we have to do? Apply x, that is equal to data frame, margin equal to 1, and function equal to sum. In previously we have written only m1 is the function. So we can write directly as this. Also we can write x margin func. F1 means function. Both the ways it will work. So here data frame x equal to df, margin equal to 1 means it will perform column sums, row sums. And to find the column sum, we have to write margin equal to 2. It is find the column sum. Now if we write margin equal to 2, 1, then see what will happen. It will just, what it will do? Function is mean. So that means average C to 1 element wise. So same matrix it will be written here. Here it is sum C 1, 2 and 1 sum. 1 means here see 16, 19. C1 to C, it is 0. It finds the C16, 19. Here I am selecting the first and second row. First row 1, 5, 10. Total is 16. 6 to 8, 11, 19. So C12 means it finds the sum of only the first column and second column. We do not require third and fourth. So DF12, comma, here means we are selecting first and second column. See, what is the difference? If I shall use only DF, what is the difference? What will be the output? Sorry. What is the output? It finds the column sum of all the three columns of the data frame. But here it is C12 means it is finding the row sum selecting from only first and second row. The total of x then from first and second row x, first and second, 2 plus 1, 3, 5 plus 6, 11, 10 plus 11, 21. 3, 11, 21. It select only first two columns. Now it is clear?
Yes, sir.
Now, see, I am using another type. Apply to this data frame one mean, that means it is average. Na.rm equal to true, that means it will remove if any Na values not available values. It will find the average. Same way here, this is the user defined function or inbuilt function that you can put here. Now it is clear. Now we have studied how apply function is used, and in all the previous example we have used this mean, standard deviation, sum, that means the inbuilt functions. Now we have to use a user defined function. Now I have defined a function like this. Function is function x, character that is false. If character equal to false, then character means it, false means it is a number, so it will find the square, x square, else it will write, convert as character x square. Now this is the function I have defined. To find the square of an element. Now I apply to that data frame with one, that is this function. Function means this user defined function where we have to find the square of the numbers. So here it finds the square of all the elements of the data frame. Now it is clear. Now using apply, we can use user defined function as well as the built-in functions. Now let us come to lapply. L stands for list. So the difference between the apply and lapply function can be used to matrix or data frame. Lapply can be used to list. So that is the difference. That is why it is lapply. Now take for example, I am writing movies, that is these 4. Then from this movies lower another variable, I am using lapply movies to lower. Then structure of movies lower. See, it has 4 characters. One by one it is writing the values of these movies. Now here I can use also unlist function. Here unlist function, here see the outcome, it is list of 4, it is coming one by one, one after another. If we write, it is in the form of a list. If you unlist it, it will write in the form of in one line. The outcome here it is written in 4 lines, and if we use unlist, it will write in one line. See, now the outcomes occurs in the form of one line. Now it is clear. You can use now apply, lapply and unlist. Hello. Hello.
স্যার বলুন।
Is the screen visible?
Yes, sir, visible আছে স্ক্রিনটা।
Now we shall go for S apply. Now we have studied apply, L apply, now S apply. S apply function, now apply function is applicable to data frame and matrix. Now L apply is a function that is applicable to list. Now S apply function, it takes list, vector as well as the data frame as input. So that is, so S apply, it is more common to apply and L apply. Apply function can be used to matrix and data frame. L apply can be used to a list, but S apply can be used to list, vector, data frame also. Now, the function of S apply is same as the L apply. Now the syntax is S apply X function. Now, for example, we have a data set on cars data. It is already available in our database. So in cars data, we can see the data set dt. See here, this data is speed and distance. If we write str dt means structure of this data frame, it will write this is a data frame with 50 observation with 2 variables. One is the speed, another is the distance. Now we have to find, suppose, what is the minimum speed and the stopping distance. What is the minimum speed and the stopping distance of the cars. So now, for minimum speed, I am using LMN cars. L apply dt minimum. And I am using again S apply. Now LMN cars, here another variable. Here see, speed is 4, distance is 2. I am applying same to SMN cars. Speed is 4, distance is 2. Now what is the difference in the output? We get here the output, speed and distance, as two separate variables. So here we get in same line, speed and distance. So just display of the output. So both L apply and S apply, they perform the same function. So LMN cars and SMN cars, they are the same output, but in LMN cars, the values are displayed one after another, and SMN cars, they are in the form of a set in one line. It is speed and 2, distance, speed 4, distance 2. It is rating. Now here the function we are using, this is minimum. This is inbuilt function. We can also use here the user-defined function. Suppose we find the average of the minimum and the maximum value. So I take this function average, F cars, S apply, dt average. This average AVG, this is defined by this. So here AVG is the user-defined function. MIN is the built-in function. So I can use here in this example, AVG is the user-defined function. So I run AVG here first, then F cars, then This is average speed is 14.5, average distance traveled is 15.0. So we have to find how many values are below average, how many values are more than average. So I write below average, this is the function. Then I use that function here in S apply and using L apply also. Now I have to verify whether this S apply and L apply, they are same or different. So I have to check identical DTS, DTL. I run. This is true. Both, that means both give same outcome. Let us verify DTS. This is the outcome, and DTL. This is the outcome. So both are same. So now we have to understand apply, then L apply, then S apply. Now here there is a comparison between the function, its arguments, objective, input and the output. Apply. Only the difference is the input. Apply, input is data frame or matrix. L apply, list, vector or data frame. Here the output is a list. S apply, it is list, vector or data frame. Output is vector is matrix. Now we have to slice a vector. We can use L apply and S apply to slice. For example, take the example of a car's data. It is available in our database. This we have already studied. Now another, it is a T apply function. T apply means it computes a measure, mean, median, minimum, maximum, whatever inbuilt function, or a function for each factor or the variable in a vector. The syntax is T apply X index function equal to null. Suppose, for example, we have a data regarding the age of different persons. They are classified into male and female. So we have to find what is the average age for the male persons, what is the average age for the female persons. So that means we have to find the evaluate the value of the function for different groups in the data. So in that case, we can apply T. We can use T apply function. See, here there is a data frame IRIS. You can see data IRIS. This is already available. You can find the summary of this data set. You can see the structure of IRIS. So that means this is a data frame with 150 observation with 5 variables. These 5 variables are sepal length, sepal width, petal length, petal width, and the species. That means this data relating to a flower, categories of flowers. Species, there are different species, 3 different species of flowers. They are measured sepal length, sepal width, petal length, petal width. That means 4 variables. They are measured from different species of flowers. So I have to use how T apply is used. So I use here T apply, IRIS sepal width, IRIS species and median. That means I am finding the median sepal width for different species. So first, this is the variable. Second, this is the categories, different species, and this is the function. So I use T apply. See, different species, we have 3 different species, and this is the median of sepal width for 3 different species. So I use T apply here. Now it is clear. Now there is another M apply. M apply function. It stands for multivariate apply. We can apply repeat function REP to replicate values. So generally repeat function REP, repeat 2, 4 means this repeat 2, 4 times. You can see here I use repeat 2, 4. 2 is repeated 4 times. Now, the vector have the values 1 to 4, which replicate 4 times to 1. So when I use M apply, that means it will replicate 1 to 4, 4 times, then 3 times, then 2 times, then 1 time. So 1 to 4, that means 1 will replicate 4 times, 1, 1, 1, 1. So it will use repeat function simultaneously several times. 2 value will repeat 3 times, 2, 2, 2. 3 value 1, 2, 4, na? Here 4 to 1. 1 will repeat 4 times, 2 will repeat 3 times, 3 will repeat 2 times, 4 will repeat 1 time. So this is the outcome. So just like this will act as if it is frequency. So general function, M apply, function, argument 2 and argument 3. First argument function, this function is to be applied. In the previous example, we have used to repeat means repeat function. The second argument is vector to pass the function. Third argument gives the number of times to replicate. So here we are creating 2 list objects. The vector blue, it is a list. Blue, it is the list. I am taking A is from 1 to 10, B 11 to 20. Blue A 1 to 10, blue B 11 to 20. So red means it is a list, C 21 to 30 and D 31 to 40. So 21 to 30 it is C, 31 to 40 D. Then red list C 21 to 30, C 31 to 40, this is red. It will write the list here. So we have to calculate the total of the values A, B from the blue list, C, D from the red list. So in that case, we have to use mapply. Mapply, that means simultaneously we are applying this function to multivariate data, means blue and red category, variable A, variable B under blue, variable C and variable D under red. So mapply, this sum is used for all these four categories: blue A, blue B, red C and red D. So this is the output. It finds the sum of the values of A, B, C, D for each category. For blue as well as the red. And here if you use mapply sum blue red, means it will find the sum of all the blue and red, means sum of A and total of A, B, A with C, B with D, blue with red. Now another function, that is split function. Split function, it will divide, help to divide a vector into different groups. This syntax is x, f, drop equal to false. Now here we can consider this example. We take blue, it is a list A from 1 to 10, B 11 to 20. Then the red 20. In the previous example, I use this split function x, f, means we split x depending upon different factors. Different factors I choose from the normal distribution. I take the values of x. One is C normal distribution, 10 numbers from random numbers from normal distribution, run if 10, or random number 10, 1. So these are the values. So I have to split the value of x into different labels. Here 1, 1, 1, then 2, then 3, 10, 10, each 10. 10 values I have selected. So 1, 2, 3, each 10 times here. We split the x by factor-wise f. So this is first factor, second, third. So another example, we can select also the air quality data. It is already available. I have to, in the air quality data, we have ozone level, then solar, wind speed, temperature in different months and days. Now I have to split the air quality by month wise. So I have to write this split air quality slash month. $month, that means it will split the air quality month wise. So split function is used here. You can see this is the output. So month 1, month 2, month 5, month 6, then month 7. So like this. So it will split the air quality data month wise. Now we have used different apply family functions and a split function. Now is it clear? Hello?
Yes, sir. Yes, sir.
So, shall we continue? So, we have covered different control structures. And then apply family. Function and apply family. I have only gone through the user defined function. I have avoided here the built-in functions, some of which covered yesterday. That means mean, standard deviation, median, different quartiles, that Tirthankar sir covered yesterday. So today I have covered only the how to define, how to frame a user defined function. Okay, any question? Hello.
Hello. Yes, sir. If all the participants are requested, if you have any question, you can write in chat box. If you have any question, you can interact directly with the speaker. Okay, sir. Thank you.
No questions yet.
No, sir.
In statistics, generally, no, not any statistics. While taking any class, we expect if there is no questions, it means we understand two things. One, that everything, whatever the teacher taught, all of them understand. And the alternative, I should not say. So I expect the better one.
Sir, I have one question.
Okay.
Sir, is there any ways by which we can connect the R and Python? That means some statistical calculation. If I want to.
Most of the R codes it will run in Python. In R, since there is a most of you, I do not know about your most of your background. Can I know your background? Most of you are from statistics or non-statistics background?
Non-statistics background.
So always better. So the remembering these codes, whatever, they are very difficult. I do not. For me, I find difficult for most of the non-statistics people to remember the codes. Except computer science people, they are very familiar with the codes and computer languages because they are mostly acquainted with that. But for data analysis, while you are using R means, don't use codes. I am giving you, because time is short. I have not gone through that. I am just in short. I am trying to explain within 1-2 minutes. You see, once all of you are acquainted with our studio. Hello.
Yes, sir.
In our studio, there is a simple in the my screen is visible.
Yes, sir.
See, there is a option here: files, plot, and packages. You just click on the packages and select install. Select install. Then this box will come. Just simply type capital R, small letter CMDR. Capital R, small letter CMDR, and then install. So once it is installed here, the list will appear here. R commander, that is, it will appear here. RCMDR. You just click on this R commander. You can see here. See, RCMDR, click on this. Once you click on this, you can, this window will change to just like to an Excel sheet. And the window that you will get, it is just like the SPSS window, your SPSS window. And in that Excel sheet, the column heads will be name of the variables, and the statistical analysis that you want to require, it will be displayed on the top, on the head analyze, just like using SPSS. So where you can analyze your data without remembering any command line. You need not remember any command line. You can make your statistical analysis completely free, and you can get all those statistical functions can be obtained by the menus only. Suppose you have to find the summary, mean, median, mode, all these things, go to analyze and click on summary. So these values will come out. You need not remember the commands for finding the summary.
Actually, I want to know, is there any connectivity between R and Python? That means if suppose I want to write a function which will calculate some statistical part, and the result will be delivered to the Python part. Okay.
You will calculate in R, and result will go to the
Python. Is
Python.
there any
that means you are going to link your R file to Python. That can be done.
Yeah.
You can use Jupyter Notebook, and you can open it with IPython package.
Okay. Okay. Thank you, sir.
Thank you. Any other?
Okay, thank you, sir, for your valuable lecture. I think all of our participants will be benefited. We are very much thankful to you, sir, for your valuable speech, and enjoy the informative session in the workshop.
Thank you, madam, for giving me a scope to interact with you. And it will be a little bit better if it is conducted in offline mode. Since online mode, it is somewhat due to network problems, there are some difficulties in expressing and
Yes, sir. We will try in future to organize a offline workshop.
And before just COVID, I went to there is a Sarojini Naidu College. There I went. Just after that, the COVID started and the lockdown started.
Yes, sir. Okay.
Okay. Thank you, madam. Thank you, all the participants, and thank you, Chairman IQAC and the Principal of PC Mahalanavis College for giving me scope to interact with all of you. Have a very good evening.
Okay,
Thank
sir.
you.
Thank you again.
Namaskar.
Okay, all participants are requested to fill up the feedback link on behalf of organizing committee. I request all participants to fill up the feedback link.
Okay, ma'am.